Everyone, welcome to Inspire EDUCARE. I am Ruchi and today we will solve question number 105 of Leetcode, that is to construct binary tree from pre-order and in-order traversals. So in this question we are given two integers array, pre-order and in-order, where pre-order is the pre-order traversal of a binary tree and in-order is the in-order traversal of the same tree, and we have to construct and return the binary tree, right? Before going into the logic of the question, let me just brief you about what pre-order and in-order traversals actually are, right? For those who are not familiar with them. So we are given pre-order and in-order, right? So let's talk about pre-order first. So what is pre-order? In pre-order traversal, first we go to the root of the tree, then we go to the left side of the tree, and then we go to the right side of the tree, right? So let's say this tree is given to us. I've made this tree. So in the pre-order, first we'll go to the root. Let me just create an array like pre-order array, right? So first I'll go to the root, so I'll just insert 1. Then once the root is done, I'll go to left, right? Now in this left also we have a tree, right? Left subtree. So we'll follow the same order. First we'll go to the root, that is 2, go to 2, and then we'll go to the left. Then again in the left, we just have one node left, so we'll just consider it root, right? So then I'll go to the left, it's 4. After I'm done with the left, right, first I was done with the root, then I was done with the left, so now I have to go to the right. So I'll go to the right, and here it is 5, so I'll just write 5 here. And now the left tree is done, right? This is done. Root, first we did the root, then we did the left, so now the turn is for the right. So now we have this right subtree, right? So now in this also we'll follow this order. First we'll go to the root, that is 3, we'll go to the left, that is 6, and then we'll go to the right, there is nothing, so we'll just come back and our traversal is done, all the nodes are done. So this is the pre-order traversal of this tree, right? Now let's talk about the in-order traversal. So I have this same tree again, right? Let me write in order here. So in order traversal, what we have, first we have left, then we have root, and then we have right. Okay, so now what will happen in this tree? Let me just write in order, right? So first we are at the root, right? So first we have to go to left, so I'll go to left. So now this is the tree. Now in this tree also, first I'll go to the left, I'll go to the left. So now I have 4, that is the leftmost node. There is no other node, no children of this node, so I have come to the leftmost part of the tree. So I'll first insert 4. Now this left is done, then I'll go back. Now because the left is done of this left subtree, I'll go to the root, right? So 2 is there, so I'll write 2. Root is done, left is done, root is done. Now I'll go to the right. And 5, again there are no children, so this must be the only node left. So I'll write 5. Now the left part of left subtree is done, right? So now the left subtree is done, I'll go to the root. So what is the root node? 1. So I'll just write 1. Now the left is done, root is done, I'll go to the right. So right tree is this. So first in this right subtree, I'll go to the left according to our in-order traversal. So what is the leftmost node of this right subtree? 6. I'll write 6, and then left is done, I'll go to the root, that is 3. 3 is done. Now I'll go to the right, there is nothing there, so I'll just end the traversal because all the nodes are now done. So this is our in-order traversal. Now in our question, we'll be given these arrays, like we'll be given pre-order and in-order. So as you can see, like this is pre-order and this is in-order arrays, and we have to return this tree. So what we have to return, the root node of this tree will have to return, right? We have to create a tree and we have to return the root node. So in this example, you can see like what is the pre-order. First we'll go to the root, right? What is the pre-order? We'll go to the root, then we'll go to the left, then we'll go to the right. Then in the right we'll go to the root first, that is 20, then we'll go to the left, that is 15, and then we'll go to the right, that is 7, right? This is the pre-order of this tree. That means, okay, so the pre-order array is matching. Now let me write in order. So first we'll go to the left, so that is 9, then we'll go to the root, that is 3, then we'll go to the right, but in right also first we'll go to the left, that is 15, then we'll go to the root, that is 20, then we'll go to the right, that is 7. So this is the in order and it is matching. So these arrays will be given and we have to return this tree, right? So this is what our question is asking us to do. Now we'll go to the logic of the question, how we will actually do it. Okay, so I have made this tree again, the one I made before, and we have the pre-order and in-order traversals. Okay, so we'll be given these two arrays in the question and we'll have to return this tree. So to do this question, I want you to make some observation first. First observation, okay, let me just write it this way so you don't get confused. First observation is this, that the first element of the pre-ordered traversal will always represent the root of the tree, right? So pre-order of 0 is our root value, right? This is the first observation. Because in pre-order traversal we are always starting with the root node, so the first element of pre-order traversal will always represent the root node, right? So this is our first observation. Second observation is this: if we find the index of this value in inorder array, right? So we have this inorder array, right? So if we find the index of this value, the root value, which is this, right, the left of this element, all the elements at the left will be the elements in left subtree, right, and the right elements till the end will be the part of right subtree. That means I have this root node, right, and in this subtree, however it is arranged, the elements will be 4, 2, 5, and in this right subtree the elements will be 6 and 3, right? Because in order, first we do the left, then we do the root, and then we do the right. That means the elements that come before the root node will be in the left subtree, and the elements that come after the root node will be in right subtree. This is our second observation, right? So these two are the main observations. Now because I already have the root node, right? I have the root node. Can I write a recursive solution for this also, for the left subtree also, and for the right subtree also, right? Because what we will pass in a function to make this tree, will pass pre-order and inorder, right? Pre-order and inorder, and this function will return root node. So this, for this tree, for these two array, this will basically return this one, the node with this one value, right? Now I've already created this one. Now I want to create the left subtree and right subtree for this, and I just have to like put the that root of left to the left subtree and the root of right to the right subtree, right? So to create this left and right subtree, I can use the same function. I will have to use the same function, right? So in this function also, what I will have to pass? I'll have to pass the preorder and inorder of left and preorder and inorder of right, right? So once I've created this left and right for using this function only, I'll just say that root of left is this subtree and root of right is this subtree, right? So this will be a recursive solution. So because we have created root, and we'll create the left and right subtrees using the recursive solution. So to create the left subtree, what we need? The preorder and the inorder. So can I say that this, let's say this inorder I'm given, right? 4, 2, 5, 1, 6, 3, right? This is the inorder of the whole tree. Now can I say, if I found the inorder of the root, right? This is, I have found the left part, the left array is the inorder of left subtree, and the right array is the inorder of right subtree, right? I can say that because the elements are already in the order of inorder traversal, and I found that these elements are definitely in left and these elements are definitely in right. So I'll just pass this array for the left subtree and this for the right subtree. I don't even have to pass the array. I'll just pass the index. Once I found this index, let's name it like index, right? And let's name this start, and this, let's name this end, right? So what we'll do, we'll have the start and end index for this inorder array. For the whole tree, it will be what? 0 to n minus 1, right? Given we have n nodes, sorry, given we have n nodes. And for left subtree, once we have found the index of the root, right? Once we have found the index of the root, what will be the like indexes, starting and ending point for the left subtree? It will be from start till the index minus 1, right? If this is the start, and this will be the index minus 1, right? Like let's just visualize it. And for the right, it will be from index plus 1 till end, right? So this is also what you need to like keep in mind. For the left subtree, for the inorder array, the indexes will be from start to index minus 1, index being the index of the root node, root element, right? And for the right, it will be index plus 1 till the end. Okay, so what we did, we found our root, right? This will be the root index. In the pre-order array, we found the root index to be 0 initially, because root is always the first element, right? So our root index is 0. Now what we will do, our root element is 1, our index is 0, and our root element is 1. So this root we'll find in this array in order, and we'll find the index of our root. So as you can see, this is our root, right? This is our root. And what is the index? Our index is 3, right? In order. So now for left subtree, I have written it here. For the left subtree, when we write the recursive solution, our start will be the same, right? And what will be the end? It will be index minus 1. This, right? This will be, okay, let me use a different color. So this will be our left, right? So index minus 1 from 0 to 2, it will be left subtree, and from index plus 1 till end, it will be the right subtree. So instead of passing like the array, or dividing the array and passing it again, I'll just pass the start and end index from which we'll have to search the elements, right? Okay. Now for the left subtree, what will be our root index, right? We have found the in order indexes, right, till which we have to traverse for left subtree and right subtree. Now we'll have to find the root index also, because the first thing that we were doing, the first observation that we made was that we found the root index for our whole tree that was on the 0th index. Now for the left subtree, when we are traversing after the root, where we are going? We are going here, right? Where we are going? We are going to the root of the left subtree. Just after we have done the root, the first place we are going is the root of the left subtree. You can see it here also, right? When we have done the root, first place we are going is root of the left subtree, and we have done the root of the left subtree also. Then where we are going? Then again we are going to the root of the left subtree of this subtree, right? So we can make this observation that just after the root is done, the next element in the pre-order traversal will be the root of left subtree. So in the left subtree, what will be the root index? Root index will nothing but we'll just increment it by 1, right? Root index plus 1. This will be the root of left subtree. So this will become our root of the left subtree, right? And then again we'll do the same, right? This will be our end in order. We'll find the index of the root. This will be the index, right? And then this will be the left subtree, and this will be the right subtree of that left subtree. So the left part will be done. We'll find a root index, right? Now what will happen with the right subtree index? How will we find it? As you can see, like for the left subtree, we just did plus 1 for the root index. But for right subtree, what is our element? It is 3, right? And where is 3? It is not adjacent to the root. It is far away from the root, which is here. So how will we get to 3? How will we get to this index for our right subtree? Right? So it is something that we need to figure out. In a pre-order traversal, where is the root index of the right subtree? Here it is, right? 3 was our root index of the right subtree. So how many elements are before this, right? If we can skip those, how many elements are before this and after our real root index? So how many elements come between root index and root of right subtree? If I can just skip to that, right? Like if I can just increment my root index to that, like the number of elements that are between root index and the root of the right subtree. Let me just here, right? Root of the right subtree, right? If I can just find out the number of these elements, right, then I can just increment my root index to that. So how will I find it out? We'll use our in order array for that, right? So in our in order array, what I have my index of the root, and I also have my start, that is the start of the leftmost elements in that tree, right? So can I say that from start till index, these number of elements are the same number of elements that I need to skip in the pre-order to get to the root of the right subtree, right? Because how many elements do I need to skip? I need to skip like 4 elements including the root, right? 1, 2, 4 and 5. I need to make 4 skips, 1, 2, 4 and 5 to get to the 3. And it is the same as index minus start plus 1. This will give you the same answer as the number of skips that you have to make, right? It makes sense, right? Index minus 1 will give you 3, and that is the number of elements that you need to skip. But I will also add 1 because I also need to skip the root element too, right? I need to skip the root element too, so I'll have to add 1 also, right? When I'm like when I'm decrementing start from index, it is not considering this element, right? So we'll add plus 1 to that so that it can consider that many skips also, right? So this is how I will get to my root right. How will I get to it? I'll just have to add index minus start plus 1 to get to the root right, and that will be the root index of root right. All of this might seems a bit confusing to you because it's like too much information, so I'll just like summarize it what is happening. So for a root, what is a root index? It is nothing but 0, right? In a pre-order, in the pre-order array of it, pre-order traversal, the zeroth index of the pre-order array is our root index. For left subtree, what it is? Root index, it is nothing but 0 plus 1, right? And for right, what is it? Now this is where it will come. We have to add to our root index the previous root index plus the index that we found in our in-order subtree minus starting point of our in-order, not subtree, in-order traversal plus 1 to make the right skips. This will be the root index of our right subtree, right? So what we have done till now, so now when we use the function for left and right, we'll get these left and right subtrees too. We'll use the recursive function, and what we'll do, we'll just add root of left to the function where we pass the left thing, and root of right where we pass the parameters for right. Okay, so then we'll get a tree. So now because this is a recursive solution, we must have a base case too. So what will be our base case? Our base case will be that our root index should be less than n being the number of nodes. Our root index should always be less than n. It should not exceed more than n, because when I'll be making the function, the parameters that will be passed in that function will be root index, start, and end, right? These three will be the parameters that will be changing when I write my recursive functions. So the base case will also be around these parameters only. So first will be this, second will be that start should be less than equal to n, right? Start should not exceed n. That will be our second base case. If any of these condition is not met, that means we have reached a null node, like that node does not exist. So we'll just return null, right? So as you can see, it is like a lot of things are happening in this question. So when we go to the code, you will understand all of this perfectly. Like there are a lot of things to kind of remember, but when you look at the code, it will seem very easy to you. Just like remember few of the observation we'll made, and then when you see the code, it will all seem a bit easy to you. Okay, so let's look at the code for this question. So what I have done is I have created another function called solve, and this solve function will return the root node, right, that we discussed in the question. So this is a function that will return the root node. So in our main function, so this build tree was the function that was given in the question. So what I have done is I have just returned the solve function and pass all the necessary parameters, right? So what are the parameters in this solve function? First is the root index, second is start, third is end, and then the other two are pre-order and in-order that are given. So as I explained in the solution, what will be the root index of our like main root node? It will be 0, right? So here I have passed 0 as the root index and start and end as 0 and n minus 1, because we are talking about the main tree, we are talking about the main root. So we'll take the whole in-order array, right? So the start will be 0 and end will be n minus 1 and our root index will be 0. So, and these are the three parameters that will change, right? Pre-order and in-order, these will be passed in all the recursive calls that we'll make. Pre-order and in-order arrays will not change, right? So there are four parts to our recursive solution. First is the base case. We just discussed that the root index, if it's greater than the size, right, greater than or equal to size, or if the start is greater than n, then we'll return null. So this will be our base case. If this is not the case, then we'll create a root node. And what will be the root node? What will be the value of that root node? We'll pass the pre-order of root index, right? So in the first case, for the first node, we'll pass pre-order of 0th. So this will create our main root node, right? Third, we'll search for that root element, the root value in our in-order traversal, right? So I've created a int variable called index, and I have run the loop from start to end, right? See, I have not run from 0 to n minus 1, because from 0 to n minus 1, that will be just for the first root. When we do the recursive solutions, the start and end value will change, right? So I'll have to pass start and end, not 0 to n minus 1. So it will run from 0 to, for first root, it will run from 0 to n minus 1, because that is the start and end. And if it finds, if the root value if it finds at ith index, then it will become I, index will be equal to I, and then we'll break the loop, right? This will be the third part. And the last part is nothing but the simple recursive calls. So what will be the left subtree? In our left subtree, as we discussed, that root index will just increment by 1, start will remain the same, and index, the end will become index minus 1. That will be the left part of the in order array. And for the right subtree, our root index, we'll have to use this formula to get to the root index of the right subtree. We'll make index plus 1 as a start, and the end will remain the same. So, and these two recursive functions will return left and right subtree, the root of left and right subtree subsequently, and we'll just put them in root of left and root of right, and then we'll just return the root, right? So this function, the solve function, will work for all the recursive calls as well, right? For the left subtrees and the right subtrees, this function will create the trees, and we'll just like add it to left and right children respectively. So I already ran it, but I'll run it one more time to just show you that the solution is working, right? It's working. I'll just submit it. So yeah, it's running, as you can see, right? So thank you so much for watching this video. If you like the video, do subscribe to Inspire EDUCARE channel for more such content, and thank you so much. Yeah, bye.